Hey guys, welcome to Empty Stack and you're watching LeetCode series of problem solving using Java, and today we are going to look at Ransom Mode. To solve this question, it is good to have knowledge on arrays and hash table. The difficulty level is easy and this question was asked in interviews for companies like Google, Apple, Adobe, Spotify, etc. Okay, let's jump into the question. We are given two strings, ransom note and magazine. We need to check if ransom note can be constructed using the letters in the magazine string. If so, we need to return true, else we need to return false. And both of these strings consist of lowercase English letters only. Let's look at an example. Suppose the magazine string is magazine itself and ransom note string is again. Now if we try to form ransom note using letters in the magazine, we see that it can be done, so we return true. But if ransom note string was gamer and we try to form this using magazine, we are missing the letter R, so it is not possible and we return false. Okay, let's try to build an approach to solve this. First thing we know, all letters are lowercase English letters. Secondly, to return true, all letters in ransom note should be present in the magazine. And not just that, if a letter occurs in ransom note more than once, it should occur in the magazine as well, that many number of times or more. So we can say if we keep count of each letter present in ransom note and check if those letters are present in magazine as well, with that much count or more, we can return true. Using this info, let's try to build an algorithm. We iterate over the magazine string and we store each letter and its count in a hash map. If a letter repeats, we increase the count of this letter in the map. So for this example, after completing all iterations, we would have something like this. Notice the count of A is 2 because it occurs twice in the magazine. Now let's look at our ransom note. We iterate over it as well, and for every letter in ransom note, we check if it is present in the map. If it is present, we decrease the count for that letter by 1. If it is not present in the map, or if the count has reached -1, we return false. Else finally, we return true. Let's see this in action. We start with the first letter A, we find it in the map, so we decrease its count by 1. We move to the next letter G, we find it as well, so we reduce its count by 1. Next is A again, so again we reduce the count. Next we have an I, it is found as well, so we decrease its count. Finally, we have an N and it is also present in the map, so we decrease its count. Since we have reached the end of the string and all values were present in the map with count more than 0, so we can return true. But what if in our ransom note there was an extra S at the end of the string? Since S is not present in the map, we would have returned false immediately. Another case could be if there was an extra A at the end. We see A is present in the map, but the current count is 0. On decreasing it, the count will become -1, and we said if count becomes -1 at any point of time, we return false. You can verify this. Magazine has 2 A's, but our ransom note has 3, so false indeed is the correct output. Now let's write a pseudocode using this algo. We can start by declaring the hash map, then we iterate over both magazine and ransom note string. We add a return statement with true at the end of the code. Now when iterating over the magazine, we want to store the current character and its count in the map. So we create a count variable, initialize it with 1, and we put it in the map with the character M as the key and count as the value. But if the character was already added to the map, we get the current count from the map, add 1 to it, and put it back in the map. Now when iterating over ransom note, if the current letter is not present in the map, we can immediately return false. If it is present, we get the count from the map, decrease it by 1 and put the new count back into the map. As discussed, if the new count becomes -1 at any point of time, we immediately return false. If we talk about time complexity for this approach, it will be O of M plus R, where M is the length of the magazine string and R is the length of ransom note. But if you notice, we haven't used one piece of information provided to us, that is, all letters are lowercase English letters. What this means is our hash map will have maximum of only 26 keys. So instead of using hash map, we can use integer array of length 26 to store the count of each letter, where index 0 will represent A, 1 will represent B, and so on. If you think about it, the logic remains pretty much same, but operation will be much faster as arrays do not require extra step of hashing while storing the data. Based on this, let's try to fix our algo. So instead of hash map, we start by declaring an integer array of size 26, same as before. Next we iterate over the magazine array. Here instead of all the hash map logic, we start by finding index of current letter by subtracting A. This would simply map A to 0, B to 1 and so on, and now in our map array, we increase the value of the element at this index by 1. Next we iterate over the ransom node, we get rid of all the hash map logic, and again we start by finding index, and this time we decrease the value of the element at this index by 1. We know that if at any point value of any element in the map array becomes 0, that would mean that this letter cannot be used to form ransom node anymore. So we add an if condition where we say if the value of current index is 0, simply return false. This line covers both the scenarios, whether the character was completely missing in the magazine from the start or its count was not sufficient enough to form the ransom node. And that is it. The time complexity will be again of m plus r, where m is the magazine length and r is the length of ransom node. And the space complexity will be constant as we are using constant space of size 26. Let's look at the Java solution. We start by declaring integer array map of size 26. Next, we iterate over the magazine string. We use enhanced for loop char c colon magazine. We convert this string to char array. Now in this loop, we increase the value of element at index c minus a by 1. Similarly, we iterate over ransom node, and this time we decrease the value of c minus a element in the array by 1. Next, we add an if condition. If the current element is equal to 0, we return false, and at the end of the function, we return true. Now we add edge case. If length of ransom node is more than that of the magazine, it won't be possible to form ransom node, so we can immediately return false. Let's run this. Perfect. See you guys in the next one.